Hello and welcome to Learning Programming AI. In this series, we are going to learn the science of AI. We are going to learn programming. We are also going to look at how do we build some real world applications. So do subscribe to the journey. Check the links in the description. You can download some of the notes and slides used in these talks. So let's get started. Let's talk about foundation models. So what are foundation models? So if you look at ChatGPT or GitHub Copilot or Claude, all of these systems actually use a large language model in the backend. And many of these models are called foundation models, which I'll explain in a minute. And they evolved from the concept of language models. Okay, we talked about foundation model. We brought up the concept of large language models, and then we said language model. So what are all these pieces? How do they fit together? So to describe this or help you understand what these models are, we need to go back to, let's say, around 1900s. If you have read Sherlock Holmes, there is a story where Sherlock Holmes finds a series of stick figures. It's a message somebody has left. Nobody is able to decipher what it is. And what does Sherlock Holmes do? He looks at those stick figures, he tries to map them to the alphabets, and he says that okay, the letter E is the most commonly occurring alphabet. So one of these stick figures which occurs a lot through the message must be the letter E. So it's a prediction or a deduction. So with that assumption, he tries to bring in what the other alphabets are through the whole system. So this was the earliest form of using statistics, using the idea of studying the language and finding out the most common recurring patterns or alphabets, using that to deduce what this message is all about. So similarly, the whole science progressed, and then we had Claude Shannon, who basically used the same concept to decipher World War II messages. So these are all different ways of understanding how a language is. What is the statistics that describes how words are related? What is the distance between words? Which words occur most frequently? Which alphabets occur frequently? So you basically build a model of how this particular language works, like English, for example. So that's a language model where you basically observe repeating patterns and try to generate more patterns based on what you have understood. So that, let's say, is a language model. So large language model is one where you feed in vast amount of data to observe all these variations of words. So for example, if there is a word called roots, and if you see a sentence which says roots trace back, statistically I make a note saying that, oh okay, whenever there is a word called roots, I'm going to expect a word called trace back. So roots trace back is a sentence. So that's how it builds up knowledge. So the more you expose it to different types of text like novels, documents, I don't know, business documents, Wikipedia, encyclopedia, the more types of relationships the language model is going to understand based on how these words work with each other. And that becomes a memory in the model, or basically it tries to retain this relationship. That's something we'll talk about. So once the language model has a good understanding of which words will appear after which one, now it's quite easy to predict what might come in a series of, if you have a sequence of sentences or words, it's quite easy for the model to make a guess at what might come next. So if you look at ChatGPT today, you type in something, it starts typing back a response. You can see the way it constructs the response for you. I mean, it could be much faster on the backend, but the creators of ChatGPT have tried to show you how it constructs this answer for you. So it will start typing, you get an answer one after the other. That is nothing but prediction using large language models. So that's the general background of what a language model is and how you train a language model with vast amounts of data, and you get LLMs, and then you use these LLMs to build tools like ChatGPT or GitHub Copilot. So you can see that most of the core value comes from the LLM. So if you look at ChatGPT, your chat interface is not the intelligence. Your actual intelligence is the LLM that's behind ChatGPT, right? So to build a large language model with so much data, it requires access to a lot of resources, it requires a lot of computing power, it requires so many things. So if everybody is trying to train the same type of model where you feed in the same amount of data, same kind of data, trying to get access to, let's say, encyclopedias, old documents, all sorts of things, it's a lot of wasted effort. So we came up, or the industry has come up with the idea of a foundation model, a model that has enough amount of data in it, which has been fed enough amount of data, and now it can be tweaked to add additional meaning over the foundation model. So a foundation model is like a building block. So the purpose of this is to make sure that all these resources are made easily available to a lot of people. What I mean by that is, it's difficult to have access to all this data. It's difficult to have access to so much raw computing power to build a large language model, and it's also difficult to get it right because you need to tweak it. So once that is done, people commercialize that and they offer these foundation models through APIs. So you can actually use ChatGPT's LLM through the APIs and build your own tool. It could be another ChatGPT or something else, or you can add additional data and you can build a much more specific task-oriented model based on the foundation model. So that's the idea of foundation model.